Good morning, good afternoon, good evening, our global audience. I'm Shirin Takanai, Chair of the Global Engineering Deans Council, and it is my pleasure and honor today to introduce to you a panel that comprises the working group established under the auspices of the Sustainable Futures Lab at the School of Engineering at Morgan State University. To begin our conversation on how to teach sustainability to all engineering professionals. Where is that curriculum? Who makes that up? And how do we implement it? As we near the 2030 deadline on the United Nations Sustainable Development Goals, one thing we can all agree on is that we want our planet to be sustainable, healthy, safe, and joyous. But how do we do that as engineers? So today it is my honor to introduce to you again a dear colleague, Dr. Claire Nelson, whose latest book, Smart Futures, I just had the pleasure of finishing, is going to lead this panel of experts to start the discussion, the global discussion on how we implement sustainability on our planet. She is joined by 5 experts from the working group from all around the world this morning, this afternoon, this evening. We do span the world. And without further ado, Dr. Nelson, the floor is yours.
Greetings and salutation. As in Jamaica we always say, and friends all. I feel as if I'm among friends because I'm certainly in the arms of my loving engineering community, a community I long to join since I was 13 years old, going to all girls high school in Kingston, Jamaica. I am the co-founder and director of the Sustainable Futures Lab at Morgan State. Thank you so much, Morgan State, for being one of the first believers in the gospel of Claire Nelson according to the sustainability principles of the world. What is important, I think, is that we recognize the role of engineering and engineers in the built environment, and therefore that impact on the natural world. And say by built environment, I'm talking about everything from the chemicals that we have used to prepare our food, to grow our food, to this structure of food, to the cars we drive, to the buildings we live in. Everything that we have touched since this morning, since we have arisen this morning. Everything we slept on has been built by an engineer. Isn't it wonderful to know that our community has so much power, never mind what those economists and financiers say? And so this is why I think as we're looking towards the 2030 goals, it's very important that the voice of engineers be loud and very much in the forefront, and not just be left to the environmental engineers, but all engineers, I believe, must become sustainability literate. And so this morning we are joined by, I've been in the alphabetical order to begin with, Dr. John Atkinson at the University of Buffalo, my alma mater. I'm very excited to be reconnecting. I did my industrial engineering degree there, who will give us perspective from somebody who's actually starting to teach a course in sustainability engineer. Then we have Dr. Blair, in alphabetical order. She's in Guyana. She's a professional transitional engineer. I'm working in terms of developing the training platform for the whole Caribbean region. We have Dr. Jacqueline Bridge, who is at University of the West Indies at the Trinidad and Tobago campus. They missed me. I was supposed to have gone to engineering school there, but I ran off to Buffalo instead. Bad me, right? She's an industrial engineer also, and bringing us another academic perspective. Then we have John Corliss, who's a professional engineer. He is in the field doing a lot of work in sustainability and environment. In fact, I must say, he's the founding chair of the Board of Sustainability Engineering at the Institute of Industrial and Systems Engineer, and is indeed a fellow there. And then my colleague and co-director of the lab at Morgan State, Dr. Oludare Owolabi, who is a civil engineer. So we have tried to balance it, and we have other members of the working group who are other types of engineers, but the idea is to have a mixture of engineers at the table from around the world. And actually, we're still in formation. So those of you who are in Asia, we'd love some Asian voices, and certainly some people from the Pacific, if there's anybody here from the Pacific. We're already fleshing out, trying to identify people in Europe in this space. So without further ado, we'd like to begin by having our conversation start with the first panelist addressing the question. I think our first panelist is Dr. Bridge in Trinidad, who will talk about the relevance of having a body of knowledge that translates across all engineers for our sustainable development agenda. She will speak for about 3 to 5 minutes, and then we take it from her to Dr. Owalabi, Dr. Atkinson, and then we go to what's happening in the real world. So the floor is yours, Dr. Bridge.
Okay, good morning, good afternoon, good evening, everyone. On behalf of the University of the West Indies St. Augustine campus, I would like to thank Dr. Nelson for inviting us to be a part of the working group tasked with defining a globally acceptable body of knowledge for teaching sustainability to engineering students. I would also like to thank the IFES, GEDC, IUCEE for hosting this webinar today, and I hope that this will stimulate fruitful discussion on the topic. Nowadays, there's very little debate that the current global consumption of resources and energy is becoming unsustainable. The associated waste and emissions that are being generated have placed a further strain on the Earth's fragile ecosystem. Yet we also know that about 10% of the planet's inhabitants are living in extreme poverty and cannot meet their basic needs. So the United Nations Sustainable Development Agenda seeks to address these issues, and I quote, is a universal call to end poverty, protect the planet, and improve the lives and prospects of everyone, everywhere. There are many professionals who will need to be a part of that process of achieving the 17 development goals, including engineers. Engineers will need to guide decision-making with respect to clean water and sanitation, affordable and clean energy, industry, innovation, infrastructure, sustainable cities and communities, responsible consumption and production. It is therefore extremely important that during the undergraduate years, engineering educators introduce students to a common language of sustainability, providing them with skills in the cognitive domain, and foster the development of a continuing interest in sustainability, working in the affective domain. We need to drive home to our students that 3 main areas should guide our decision-making in engineering. First, we must teach our students that as engineers, we must be conscious of the technocentric constraints that we're working with. Engineers must propose innovative and creative solutions to any problems that are identified. The technical skills, the ingenuity required, the consideration of the economic systems within which these solutions are deployed have traditionally been the focus of engineering programs worldwide. But just as importantly, we must teach our students to be conscious of the sociocentric concerns. They must realize that their engineering designs and activities will affect society. In particular, they must acknowledge that the needs of human beings to live productive yet comfortable lives, and they must ensure that their designs and activities have minimal adverse effects on our stakeholders. Finally, we must address the ecocentric concerns. Our proposed solutions must be consistent with the ability of the planet to sustain us. We must consider the materials and the energy resources that we're going to use in our designs, whether they're designs of products, processes, or infrastructure. And we must take into account the emissions and waste that will be generated over the life cycle of the product that we do. Sustainability can be thought of as that happy medium where all 3 sets of constraints are satisfied, and sustainable development is a process of providing these economic solutions that are consistent with these 3 areas. Within our engineering programs, we teach our students how to design and how to make engineering decisions based on available data. Inclusion of sustainability concepts is definitely necessary so that our students understand how to develop holistic solutions. For example, we teach our students that an important design step is framing the requirements and traditionally that has focused on understanding the business, the customer, and the user needs. However, a sustainability approach will widen the pool of participants with whom there is initial engagement, bringing in those different points of views and allowing us to consider the interdependence between the economic, the social, and the environmental concerns, so that they're highlighted at the beginning of the project and are continuously kept in focus as we go through the different phases. This will reduce the likelihood that we will meet resistance later in the project, and it's surely something that our students should be exposed to. When we're talking about scoping our decision, or planning and design, we need to take a cradle to the grave approach. We need to ensure that our designs are maintainable, that the design life is appropriate for the use of for the product that we're dealing with. What sort of energy sources are we using? Is the energy source justified by a long design life? Are we using any non-renewable resources? And have we taken into account the end of the usable life of the product? Can it be disassembled? Can we reuse? Can we recycle? Our students have to be aware of the overall framework within which engineering design and practice has to fit. That means that the social, economic, and environmental concerns must be taken into account when developing solutions and when planning operations. We need to consider the consequences of any implementation that we have into the future. So sustainable development and sustainability have to be critical components of our engineering curriculum, and there should be a common foundation which is globally relevant and covers all types of engineering programs, hence the need for this working group. Thank you.
So thank you so much for getting us out the gate. Again, the question is, why is this important? And we have gotten a good answer. So we're going to move now, continue in academia. We know what's the relevance, but how do we actually make change? You know, engineers are supposed to be at the head of change making, but sometimes in academia, we can get pretty rigid about where the borders lie. And we're talking about a very volatile, ambiguous, complex conversation. And so how is it we're going to get all the engineering disciplines to agree that this is the 5, 6, 7, 8, 9, or 12 things that their engineers need to know? So when they go out into the world to be employed to help companies do the right thing or governments do the right thing, we're on the same page. So we're going to ask Dr. Owolabi to help us with that. He's sort of in two minds because apart from being in academia, he also sits on one of the state boards in transportation engineering in Maryland. So he might have a sense of how it is that academia has to work to create that change process within academia across all engineering. Dr. Owolabi, the floor is yours.
Thank you, Dr. Nelson, and thank you, Dr. Bridge. In Transportation Research Board, I'm honored to be a member of the committee that considers the effect of climate on transportation infrastructure. Our kids, even starting from elementary down to the university, everybody is concerned. You don't need to tell anybody that what is happening, the climate crisis. We can see in the past few months, globally, there has been a great awareness. It's something that we can see. It's something that we can visualize. It's something that everybody experiences. This climate crisis. So it is time for us to wake up. It is time for us teachers, academicians, to wake up and to start to inculcate in the kids that we teach, starting from K to 12 down to college, how do we come together? Because come to think of it, engineers, we create. So as we are creating, be it infrastructure, be it machines, whatever thing that we create from what God has given to us, we have to start to think about sustainability because it is our children's future. How do we ensure that as we create, as we plan, as we design, as we construct, as we operate, as we maintain all this?
It seems as if we have a technical glitch here.
Systems, we are
Okay.
thinking about sustainability. We are replenishing it. How can we ensure that? So we begin to inculcate that into our curriculum. And here at Morgan State University, we are trying our best in the Department of Civil Engineering, in all our courses. We have started to incorporate sustainability. Actually, we have a senior course which is called energy energy efficiency in buildings, in which we prepare our students to be accredited by the Leadership in Energy Environment Design accreditation body, so that when they start to design infrastructure, they start to be innovative, they start to ensure that the good air quality. And more than that, we start to tell them this is what is causing this climate crisis. You have to reduce the carbon footprint. And the present administration, everybody agrees with us, whether Republican or Democrat, that there is something happening. So we are the agent of change because we have the power as educators to influence the way the as future engineers we create. So waste reduction, conservation of energy. So when you are designing anything energy efficient, awareness and education, we have to create that awareness. We have to, folks, as educators, when we create this awareness as educators in our curriculum, everybody starts to think about sustainability in all aspects of engineering. We start to think about sustainability, water efficiency. You know, in that Venn diagram of sustainability, we have the environment, we have the social, and we have the economy. The intersection of that to be cost effective, because the dwindling financial resources, how can you be cost efficient? How can you optimize? So we begin to create engineers that are innovative, that are creative, that can optimize and begin to think how to reduce the carbon footprint. And then we are going to leave behind better world for our children, better environment for our children. I will end with this, whether we like it or not. In the next 25 years, I think we'll be done with fossil fuel vehicles because there is a lot of research that is going on. How we can bring down the one that is the major driver for the high cost of electric vehicles, the major driver is the cost of the battery to store the energy. It's about 15,000. But there's a lot of research going on to reduce it to 5,000. Just imagine, as that is accomplished, we're going to have an electric vehicle that is just $7,000. So who
Dr.
cares
Owl,
to buy
I'm gonna have to
20,000?
stop
Thank you.
you because I want to get
Thank
everybody.
you.
I hear you getting fired up, so we're
Yeah.
gonna go straight to Dr. Atkinson, who is at University of Buffalo. He has is the founder of the new master's degree and professional certificate in sustainability engineering, and we're so delighted to have him talk about what he has learned so far. I mean, who is taking his course and how is it being received across the different disciplines on his campus? Dr. Atkinson.
Thank you, Dr. Nelson, and thanks to all panelists here. Thanks to GDC, IFEES for providing the venue to share and contribute. This is such an impressive panel and working group to be a part of, and I'm really just excited, frankly, to see where it goes. So, you know, just to provide a little bit more context on my background, I'm the Stevens Chair in Engineering Sustainability at the University of Buffalo. I'm an associate professor in environmental engineering. My research focus is waste management. So I'm sort of all in when it comes to research, teaching, and even service in the realm of engineering sustainability. As Dr. Nelson said, I teach an undergraduate sustainability course. It's growing in popularity. It's growing in enrollment, which is fantastic. I also teach a sustainability engineering study abroad course. It's the most popular study abroad course on our campus. And we go to Costa Rica, we study their energy systems, their social systems, and things like that. And then also, about 3 years ago, we created an engineering sustainability master's degree. And so I direct that and I advise the students, and it leads to lots of fun conversations. But again, all of this is to just say that I'm entrenched in engineering sustainability. And most importantly, I get to talk to students about it all the time. So I have a fairly good sense of what the students are looking for, which ultimately my belief is that faculty respond to student demands, not the other way around. And I think students have their finger on the pulse better than most of us. And so it's really a privilege to get to chat sustainability with them all the time. So Dr. Nelson asked me to talk about what I know so far, and that's a very humbling question, because the number one thing I know is that I have a lot to learn, especially in engineering sustainability. I think it's dynamic, it's changing, and as a result, it's a continuously evolving body of knowledge, and you know, recognizing that is very, very important for me. Learning from the students is very, very important to me. Learning from everybody here throughout the world is very, very important to me. So with that said, I'll give it a shot, and I'll pass along some info that I've sort of picked up over the last few years, again, largely from interactions with students. So first and foremost, you know, what I think should ultimately be one of the main reasons we're here is I know that students want more. They, as I said, I truly believe they have better foresight, they're more engaged, they know how to use their phones better than all of us. They know what's going on, and they want engineering sustainability content. They're practically begging for it. I have an endless line of students outside of my office that just want to chat sustainability. It's tricky sometimes to get the rest of my work done, because it's fun. These are wonderful conversations, and they know this is the correct path forward. So that's the first thing I know. Students want more. The second is that students see through rebrands. And what I mean by that is a lot of folks are putting the word sustainability in front of anything. You know, all of a sudden we have green engineering, and we have, you know, environmental and sustainability engineering, and they can see through that. To them, it is not just a word. Sustainability is not a buzzword. It absolutely must be backed by innovative and thoughtful curricula. They aren't just trying to you know, improve their CVs. They genuinely see sustainability and sustainability engineering as a lifestyle. It's a passion. It's a commitment theirs. It is not a choice, frankly. It's a must do, as the previous speaker said. And so they want to make a difference in their lives and their jobs, and they know that engineering sustainability is how they're going to do it. So that's the second thing. I know that engineering sustainability conversations can't happen in vacuums. And what I mean by that is that these conversations absolutely require diversity. And I mean that in every sense of the word. They must include folks with different backgrounds, different experiences, different beliefs, different worldviews, different countries, different genders, different ages, and everything in between. This is, in my opinion, engineering sustainability is how, at least in the US, we advance past a lot of the stereotypes that have traditionally been associated with engineering, and frankly, what a lot of the folks on this panel have done a wonderful job, including Dr. Nelson, of breaking some of those stereotypes. So I think engineering sustainability is very much a path forward. I know that sustainability provides an opportunity for students to differentiate themselves. And when I say that, I don't just mean differentiate themselves from their peers and get a leg up on the competition, so to speak. It's an opportunity, and this might sound a little abstract, but to differentiate themselves from robots and from computers that will absolutely always be able to solve math problems faster than them and more accurately than them. So I think with a sustainability engineering curriculum, we have an opportunity to teach things like ethics, humility, empathy, kindness, creativity, systems thinking, communication. These are words that have all too often been left out of traditional engineering curricula in favor of things like, you know, a sixth fluid mechanics class or differential equations 7. You know, imagine a community of engineers that have been trained in ethics and that are taught that empathy is the priority. This is how the world changes. This is how the engineering field advances. And last but not least, I know that no department owns sustainability. And this is really a tricky one. The subject is inherently broad. In fact, no school owns sustainability either. We have to collaborate with scientists. We have to collaborate with artists. We have to collaborate with folks that don't have formal education or training. They have just as much to add to this topic as any of us that, you know, went to school for 100 years. And so this is an opportunity to work together to develop curricula that provide breadth. Just as an example, our engineering master's degree requires courses in ethics, in energy, and in economics. And I think that's just a start. I would describe that as sort of the bare minimum. We're tasked with developing curricula that provide the inherent depth that's linked to sustainability, but also, I'm sorry, the inherent breadth that's linked to sustainability, but also depth. So it's really a challenge, and it requires us to work together. So with that, I'll wrap. Thank you for the opportunity to say a little bit of what I've learned in the last few years thinking about this basically all the time, and I really look forward to ongoing discussions with this panel and the community beyond. So thank you, Dr. Nelson. Thank you, panelists. Thank you, GDC, IFEES, and more.
Thank you, thank you, thank you. And now we move to the people in the field. Dr. Nebert Blair is in Guyana, and she's very involved in supporting you know, different scientific and energy transitions in the region. And she's a mechanical engineer, but also studied something called transition engineer. And I thought that was really great. Having heard about it in theory, I met the first person who actually did a degree in that. I thought she could give us some answers around the question of, okay, so you're in the field, what does the market need? What is it that governments in small island developing states need? What is it that companies in the small island developing states need if we're to design communities that are sustainable, design products and services that are sustainable? The floor is yours.
Thank you, Dr. Nelson, and thanks to the host and the fellow panelists for being here, and happy to share on my views of how to move our development on a whole going forward. Just a little bit more on some of the work that I've done. I've as Dr. Atkinson would have mentioned, sustainability seems to be the buzzword, especially in the corporate world, where we try to attract funding that is in that line available to the public and private sector. And as part of my job, being with the GIZ and working with energy, those are some of the key things that we tend to look for in a program. Now, having come from academia and having studied the whole realm of what really exists in terms of how engineering is done, more or less to understand what we do, in my work, there are a number of engineering facets or methods or systems that we would come across when we look at engineering design on a whole. So in terms of engineering, I would say, first of all, it's trying to find a solution to a problem that exists within the society. And so we have identified numerous ways of doing that. Like we said, sustainability is inherent in what we do. However, we have looked at concurrent engineering. We have even had such things as collaborative engineering, collaborative innovation, transition engineering, which I'll talk specifically about. We've looked at something called universal design that looks at 7 principles of universal design. Product design, where we try to design a product based on what the customer wants using quality functions and the house of quality for those who are familiar with manufacturing management. Design for X, where we tend to want to know what the customer wants and we design for that. Inclusive design, humanitarian engineering, and in terms of non-engineering designs, we looked at things like sustainable development, sustainable community development, design for community, you will hear a lot about that, change laboratory, fabrication labs or fab labs, and of course, lately we have what we call smart villages. So there are a host of different schools of thought and methods or approaches that tend to want to incorporate sustainability into the realm of designing. Now, as it comes to transition engineering, where I was more or less focused more on, given the other forms of engineering after studying manufacturing engineering at Cambridge, transition engineering tends to allow for the merging of experts. All right, it is similar to what we consider with the story of the 7 wise men and the elephant. I don't know how familiar we are on that story of the 7 wise men and the elephant, when the king, he wanted to find a solution and he called the 7 wise men there and he asked them for a solution on the different things. And we can look at that relatively to what we do. We can say, okay, there's a nation of people and you have problems with water, food, energy, school, health. We have all these problems that we're trying to find. And of such, we have seen where our scholars have tried to find a single matrix to define what this should be. Whether or not it works or whether or not it fits, it's a whole different story. So a lot about what transition engineering is about is trying to find a fit, or more or less to redesign and redevelopment of existing systems to allow for a downshift, whereby we have an ultra low material, energy, and natural resource consumption. So how do we do that? How will that ever be possible with a growing population? So we have already identified what is a wicked problem. And so the first thing is for us as students beginning to learn transition engineering or beginning to answer the sustainability challenge is to identify what is the real problem. It's a wicked problem. It's a problem we created and we will continue to create as we find solutions. So the answer always comes with understanding how to define the problem. And I come back to the story of the 7 wise men and the elephant. And in terms of defining the problem should not only be defined from one perspective. So as an engineer, we have to be able to really and truly have an in-depth understanding of engineering sciences as much as we can and we can do, and also be able to collaborate with our colleagues, right, in a way that will add value to what we're going to provide. Because we generally come up with solutions. We have the tools. I've listed some of the approaches we've used, and there are tools associated with each approach. Even in transition engineering, we have a 7-step approach in transition engineering. And what that does is that it looks at the past. The first step is looking at the history of the past 100 years. to see what was done. So now we have allowed for our engineering students to appreciate history, appreciate how things have changed through time, see what was done and understand why it was done, see what was done in terms of the social aspect, listen from the sociologists, anthropologists, scientists, in terms of human, social and environmental well-being, listen to what persons have to say in that regard and try to filter it out, because to be fair, the answers aren't there yet. So when we say we want to teach something to our students, it's not as though, okay, students, I have the solutions and this is what will happen. No, we are trying to create a new kind of pedagogical thinking that people will now be able to internalize a problem, reach out to the relevant groups of scholars within what exists in our world, and together devise solutions. So I think that aspect of engineering is what I find very creative and innovative and required for the transition we need. So going back to the story, so I'm telling like 3 parallel stories here. So going back to the story of the 7 wise men, they all had their own talents, but yet they could not have identified that it was an animal just because the king had blindfolded them. So our blindfolds in the real world will be our discipline. We're trained to focus on our discipline. I'm a mechanical engineer, I just do mechanical aspects. I know that the motor needs some kind of magnetism and electrical excitation, but yet I tend to focus on the mechanical aspect. So what we have to do, or what an engineering syllabus will need to inspire in our future generation is for them to now remove that blindfold. Yes, I know to do this, I know to apply the science, but let me think outside the box to find a solution with my colleagues helping me. Similarly, with the 7 wise men, to end that story, they were not told not to remove the blindfold, but they kept the blindfold on and they couldn't see it was an elephant. So I'm just wanting to say that in a university, in a college where we have all the different faculties, like Dr. Atkinson rightly said, no one owns the sustainability mantra. It is something that must be shared amongst us across the board. And together we create more or less what we call clinics or labs or whatever you want to call it, whatever innovative word, where people learn how to work together with communities to find solutions. And I think that's a core aspect in any sustainability teaching at our academic institutions that we should seek to develop and implement. More or less working now in the sector, I see that we need it more than anything else, because there are lots of things that happens when it comes to policy development. And so engineers must also be welcomed into that discussion on policy, so that we are sure when we create a policy, it makes sense. We want to go to 50% renewable energy by 2050. What it is that is required. We do the same transition engineering step, it will take a transition. So we look at the past, what was done, what was required, what we have, what will happen if we continue doing that. And in the next 100 years, what do we want? So we draw a picture, we develop what we want, and then we go back and we say, okay, what projects must be done to realize what we want? And so now the main aspect is for students to think about what projects they will develop so that they can have that with their colleagues. And so that is where the transition is, so that when we get to 2100, given our current state, we will be able to be using less and be able to live a comfortable and happy lifestyle. So in my view, that is what it will take. It will take more than just educating persons about the different disciplines. It also takes a collaborative approach into us working together to find a solution, especially when it comes to the real world. The real world is very harsh for students when they get out with their knowledge.
Thank you so much. It's interesting you mentioned the year 2100, as my book, Smart Futures, does actually have a chapter, a story that's set in the year 2100, where we would have changed the metrics that matter from GDP and GNP to gross national well-being, and hopefully engineers will have a say in ensuring that that well-being that we're looking for all humanity becomes something that we have contributed to. So we're going to have the last word in terms of before we have question and answers from John Corliss, who is also in practice, and he can talk about somebody who has been trying to build sustainability literacy within the discipline of the industrial engineering fraternity or community, what his practice has taught him about making change in that sector. So John, the floor is yours.
Thank you, Claire, and thank you to the hosts of this and the other panel members. I think a lot of the things that I want to say sort of tie in to different pieces of what has been said before. Claire mentioned, it's not just environmental engineering. A lot of people go back to Silent Spring and say, that book started the environmental engineering movement. I would not be the only one who would say, well, that's only a part of sustainability, and that the book Limits to Growth actually got people starting on the conversation around sustainability, where that was based on work that Jay Forrester had done, that Dana and Dennis Meadows worked on, where they modeled taking a systems view and using a dynamic simulation approach. They looked at the major systems of population and pollution and economic growth and resource extraction and energy consumption, and looked at over 100 years of how did that work, and then what was the future going to look like with a business as usual approach. And this was in the 1970s, and their conclusion was that in about 75 years we would exceed the Earth's carrying capacity, and that there would be a crisis for both the Earth and for the people who live on the Earth if we continued with business as usual. But if we made some very small changes, just like compounding interest, it would have a compounding effect and we could reach equilibrium. Well, we also talked about people being in their own silos, and people came out and was not welcomed well, because it was like, well, who do you think you are? Why do you think that you know about energy systems, or about population growth, or about this? You're just overreacting. And 40 years later, you look at the actual numbers, and we're trending on the business as usual case. And next week there will be, a conference in Scotland where world leaders in sort of a panic are trying to figure out how to do in 10 years what they should have been doing 50 years ago. So I give that as an example because I get asked a lot, well, what do engineers have to do with this? And what do industrial and systems engineers have to do with this? And I say, we started the conversation. And it was through simulation modeling and those kinds of things that we began to understand the problem. 10 years ago or so, at one of the IISE conferences, pointed out that, and it was pointed out the Venn diagram of sustainability. I said, industrial engineers for over a century have been focused on the intersection of the engineering sciences, the economic sciences, and the social sciences. And who better than somebody who has been at that intersection to deal with the intersection of people, planet, and profit? And we've been trained in how to convene multidisciplinary groups and come up with something that's greater than the sum of the parts. And we don't own any particular thing. So we could take a leadership role in this. We should take a leadership role in this. And, unfortunately, a lot of people, they're much more comfortable focusing on sort of the transaction level things and the small things that can be improved, rather than looking at the big picture thing and pushing themselves up the sort of decision food chain up to the policy levels, where things like limits to growth and other things actually came into play. And unfortunately, I saw an article recently, because one of the things I had noticed is that a a lot of the people who are involved as chief sustainability officers and things like that, they really come mostly from the liberal arts side, from journalism, from business, because they can see and articulate the problem, but they admit they don't know how to come up with the solution to the problem. And I saw something where somebody said, we got into this position, and then we didn't know of anybody who had any tools to actually fix the things that we saw. We just knew they had to be fixed, so we made them up ourselves. And I found that very frustrating, because I knew that industrial engineers have been working on how to improve processes and reduce waste and reduce energy consumption for decades before things like net zero housing and zero waste became buzzwords. That they had been working on how do you position facilities to be in an optimal way long before smart growth was a thing. That they had been working on operations research and using data long before data analytics and smart cities became a thing. They were working on systems thinking before circularity became a thing. But we do a terrible job of telling the world that we're doing these things. And so people don't know, and they go out and figure it out themselves. And we are our own worst enemies in that. And I think where the problems are is that in academia, I totally agree with Dr. Atkinson. The students I talk to, they realize that industrial engineering tools can help change the world. But in their curriculum, when they have a co-op or they're going off to do research, they're going to help improve the profitability of John Deere or Boeing, or they're going to help, FedEx or Amazon deliver your package a day earlier. These are maybe important things for some people, but it's sort of like rearranging the chairs on the Titanic. It doesn't deal with the big picture items that really need to be addressed. And I think us as practitioners, we don't do a good job of setting a great example either of playing in that bigger space. And I guess, where I'm going with this is that I think we all need to be thinking not just about how we can fix the little things, but how do we demand a chair at the table to be talking about sustainability at a policy level, and how do we inspire students to do that rather than thinking small? Otherwise, we're all sitting in the stands or on the bench while this game is going on that is going to determine whether the planet survives or not. And we have the tools to actually be able to help turn the tide, but we're not standing up and saying, hey, coach, put me in the game. We're just sitting in the stands and watching. So we got to get out of the stands. We got to get on the playing field, and we got to do some of this stuff. And the young students really want it. We just have to be the examples, and we have to demand that we're going to be having an impact and having our voice heard. So that's my 2 cents on tying some of the things that other people have said along the way. So thank you, Blair.
Thank you so much, John, for summing that up like that. So you have it, folks. We have 10 minutes. Actually, not even 10, we have less than 10 minutes to go before we must shut down. I just want to say something about what this working group is not. It is not an academic exercise. I have lived for 30 years in the belly of the development community trying to make change, especially for the developing countries, whether it's funding from the World Bank and all the other regional development banks are building, roads, schools, setting policy. And I do believe that we certainly, if we do this working group right, especially because we're launching it with this webinar to two very influential groups, which is Global Engineering Deans Council and the International Federation for Engineering Education Societies. These are organizations that can actually implement what comes out of the working group. When I think about this, my big dream is to say, if we look at our work as part of SDG 17, partnerships for the goal, then what we're trying to do is develop a body of knowledge. We would love to hear have somebody from chemical engineering. I haven't found anybody in that field yet. We'd love to have somebody from petroleum engineering join our working group. We really want to have at least one person from every engineering discipline. So hopefully I get some calls and some emails. You can find me on LinkedIn, Dr. Claire Nelson on LinkedIn, and say, hey, I'm interested in finding out more. And we will be starting a group, a community on LinkedIn that you can join to follow what we're doing. But the vision I have is that what if all the universities that have signed on to be the university compact to implement the sustainable development goals were to say, hey, we want to be the ones to adopt the sustainability literacy approach for our engineering school. This is a doable thing. If you've already pledged to support the SDGs, it should be fairly simple to pledge to when we come up with this body of knowledge that every undergraduate student should know, every graduate student should know, and if you're running professional courses, here's a 6-week or a 4-hour or an 8-hour seminar that you could offer to introduce these concepts to your alumni engineers, for example. That's a very simple ask. The second thing is all of those companies that already signed on to the Global Compact, there's absolutely no reason once we have this body of knowledge that we shouldn't be saying to their chief sustainability officers, here, there are 75 universities around the world or 300 universities around the world that have agreed that all the engineering literacy courses provide this information. You are building planes, you are building ships, you are making fertilizer, you are building cell phones, etc. You are doing mining over here. Here's this body of knowledge that we're saying our universities that have signed on to this can provide. That is the partnership that the engineering community can provide. And this is the leadership that by being supported by Global Engineering Deans Council, thank you so much to Dr. Serene for agreeing last year to host this conversation that got my idea from this a dream to a practical thing that's starting this journey together. So if there are any questions, I'm not sure if there are any questions from the floor, I'll take them now. But otherwise, I'll turn the floor back over to Professor Serene.
Thank you so very much. I think I held my breath, forgot to breathe through this panel. As you well know, the Global Engineering Deans Council was formed in 2008, before the Sustainable Development Goals were formulated. In 2008, the National Academy of Engineers had the Grand Challenges, which is a precursor to the Sustainable Development Goals, announced. And our reason for getting together was the planetary emergency, the call to respond to planetary emergency, which unfortunately, thanks to the myopic business as usual, not doing things we should have been doing the last 50 years, as John was saying, is more urgent than ever. So this webinar, of course, is a prime example of the kinds of things that we should all be doing. And I don't want to take up too much time from the audience questions, but I need to note several things. In our 2019 conference, a year after we rolled out the initiative of peace engineering, which is a short, loving term for meeting all the sustainable development goals. That's how peace can be engineered, because peace is an engineering problem now. It has sustainability in its heart. We will not have peace on earth until we have the sustainable development goals met. A year after we rolled out that initiative in 2019 in Santiago, Chile, against an interesting backdrop of uprisings, we issued our position paper on peace engineering as IFES GEDC. So we will join hands, we will continue the work. This is a seminal seminar for that reason. I've taken lots of notes, we have our homework. And now I'd like to farm out some questions. We have Cindy Cooper who would like to ask her question. We'll unmute her, and there are other questions coming in through the chat window. I'll try to farm out to you, Claire. I think you can see them also. So
No,
Cindy, okay, I'll farm them out to you. Let us hear from Cindy Cooper. She's from Remelson Foundation, who's an organizational member of the GDC.
Gosh, thank you so much. I hope that this works. My internet has been really glitchy. It's been fading in and out. So I apologize if that happens. I just am so inspired and excited by the work of this group. It's very much aligned with things that we've been obsessed with over the past few years. And, you know, we've been collaborating with faculty who are exactly like you know, trying to address this need so that all engineers across all disciplines are gaining this sustainability literacy. You know, it is not the work of environmental engineers alone. You're absolutely right. Every single engineering discipline is impacting everything around us. So this is absolutely critical for all engineers. And we've been trying to figure out, you know, what is it? What is that body of knowledge? What are the learning outcomes that all engineers would need? And we worked with hundreds of faculty to co-create a first draft of that, and that's called the Engineering for One Planet framework, and it has core and advanced learning outcomes on those different topics that you all talked about. And we would, you know, love to have your feedback on that, see if this is a helpful tool for what you're trying to do. We've also funded seed grants to 5 universities to take that framework and test it, you know, in different engineering disciplines through different methods of curricular change that they decided to pursue for their own institutions, depending on their situations. And so we're taking what they're learning and sharing those lessons learned and revising the framework, and then, you know, trying to make it easier for other schools to create changes. So curious if this would be beyond the, like, what do people learn? What do students need to learn? That question about how do we create the change? It's so challenging to create curricular change, and really interested in, you know, some thoughts about what you think could be highly impactful ways of making changes, of influencing changes and the acceleration of that. You spoke about the importance of students and the importance of industry, and I completely agree. But yeah, curious what you think are the most, like, you know, powerful ways to start to accelerate these kinds of changes as well. And thanks so much to GEDC and IFES and all of you for bringing this to everyone today. It's amazing.
Thank you, Cindy.
I don't think I have time to answer your question in full, but you said 2 things which are music to my ears. 1, you have a framework that you've been working on. 2, you have a list of universities you have actually talked to. And 3, you have actually funded something. So as I said, it's not supposed to be an academic exercise we're doing here. We are trying to do the actual change process. And I do believe we can accelerate that if we work together more assiduously to work across boundaries and borders. So I would love to speak to you when this conference is over to see how can your foundation bring its resources, its connections to the table. So by the time we come back next year, IFES will have this online, ABET and all the other accredited bodies can have this online. And like I said, all the universities that have already signed on to say they're supporting the SDGs, that's an easy target to let us get this going with them. But let us work together, use what you have done in terms of what you have studied, what John has been teaching, what Dr. Bridge has been teaching, etc. See where the commonalities are and have a baseline. And more important, if we are able to provide that core training and workshops for those professors who want to now teach and design that course, why shouldn't we offer that as a body of knowledge training program that people can tap into? Why shouldn't we have a lab platform that people can go in and find film or examples or case studies that they can use? So that's the kind of thing that we should be doing in the next 12 to 18 months. Certainly, I would like us to accelerate to the point that by the next 12 months, we can have a conversation with those engineering schools that are already, those universities, sorry, that have engineering schools that are already signed on to the SDGs as a starting point to take up whatever it is we come up with as an agreed on body to start with.
Thank you so much. We might add the academic extra 5 minutes to a couple more questions, but before I go on to the next couple questions, Let me note that our colleague Dawn Bonfield, who's a representative of the World Federation of Engineering Organizations, would like to get in touch and keep in loop with this working group to see how the World Federation of Engineering Organizations can be involved. Of course, they're the ones who created or co-created the UNESCO report that you referenced. So it's very nice to make this connection here. Thank you for being here, Dawn. We'll go on to maybe a couple questions if we can still, we're on the hour, but does everyone have 5 minutes? Thank you. We have a couple questions from Paul, couple short questions. Paul Shaw, he's asking, Dr. Atkinson, what do you believe students think is the single best skill to learn?
That's asked in an interesting way. I think our existing engineering curriculums train students to think the single best skill is who can solve math problems fastest. And I don't think that's correct. To me, I think we need to incorporate empathy into engineering curriculum. That would be the one that I would bubble up to the top of the list.
Thank you. And there's another question for Dr. Jacqueline Bridge, again from Paul. What is the starting point for convergence?
I think in all engineering fields, we have to take some account of what our requirements are when we're going into any design, any setup of a system. So I think the starting point would be to expand our stakeholder involvement as wide as possible in the early segment. So in our design process, in teaching design, we need to teach our students that they need to have a broad field of participants in the requirements, the design requirements development.
Thank you. Before I go on to the last question, there is a note from Elsie Mayo. Thank you, Elsie. They're iterating that that positioning this working group as an initiative of SDG 17 partnerships for the goals automatically will put it on a higher policy level, and it signals the essential transition to inclusive collaboration and problem solving. So thank you very much. It's great to make these connections here. Last, I would like to go back to one of Paul's questions and direct that to Dr. Nelson. What pearl of wisdom would you impart on a 30-second TV commercial?
Smart Futures for a Flourishing World, name of my book. I'm going to say, we have to stop focusing on smart things, smart cars, smart houses, smart watches, smart bags, smart clothing, and focus on smart futures. And we have defined SMART to be sustainable systems, M is meaningful metrics, A is aspirational agency, R is robust resilience, and T is transformative use of technology. Let's get smart. That's my 30-second and.
Beautiful. Thank you so very much. It has been a pleasure and honor to welcome you all to this platform. Before we say goodbye for today, I would like to turn the microphone over to our Executive Secretary of GEDC and Secretary General of IFES, Professor Hans-Jürgen Hoya, who has a couple announcements to make. Be well.
Thank you. Thank you very much. I have a few comments. One, I'm frankly deeply inspired by all of you. This has been, and I wish we could have planned to have this an hour and a half. I think there's still the intellectual and emotional readiness because each of you have brought insights and perspectives which are just amazing per se. Point one. Point two, I want you to know that the IFES GDC community, we will share this video here very broadly. And I think it's really worthwhile. I know we all, in contact with many online experiences. This is one of the most exceptional ones, and I'm just really pleased, Claire, for your leadership and bringing all of this together. And the seed I want to plant is I'd like to do this again and not wait a year, but to do it over the next few months. And it's very interesting. There's some very good colleagues and friends, both Cindy Cooper and Dawn Bonfield and so forth, that I'm very much in touch with. And they were inspired, the different roles that they play in the different contexts, by what you've said. I just want you to know this has been a very special place. Let me just change totally, and of course thank all of you per se. Just a couple of things. I'm privileged to work very closely with some key leaders in Europe and Spain and globally. Our forthcoming Madrid conference, where the global community of IFES GDC comes together on a yearly basis. Of course, it's a different world. It's virtual, but many of us, or a number of us, will be there in person. And some of the topics that you have so brilliantly articulated are part of the agenda without going to context. One key critical thing that I'm very inspired by is the engagement of our students, by the way. And John, one of your presentations, but all the several presentations, I'm going to facilitate some connections. Some people call me I'm the troublemaker because I'm going to add some more interviews for you to pursue per se. Because what I've heard, I think they would be very inspiring, and you could learn from them. That's the key point, and I think that was the tenor of all of you per se. I want to just mention that. The other thing, in terms of our global community, and just finally, that has been just very inspiring, working particularly with women leaders throughout the world. We're publishing now our editions on Africa and India in the next week or two of Rising to the Top series of books per se. I'll share some insights into that per se. And this is an important piece of our global IFES GDC community. I'm very proud of working with the kind of leaders at a global level that we have been able to do that. So just Shirin, thanks very much for being here and introducing. As I said, Claire, I'd like to find soon another opportunity for this group to come together. Peace be with you, stay healthy, and all the very best to all of you. Thank you.
Thank you all very much. Stay safe, everybody.
Bye-bye.